All right, let's talk about adding algebraic fractions. So what I mean by that is fractions that have pronumerals in them, using algebra. The most important thing to remember is the rules of fractions don't change. I can't add these together because at the moment you'll see they've got different denominators. So I need to write them both as equivalent fractions that have the same denominator. And remember, my techniques for doing that is I've got to find the lowest common multiple. In this case, what will be the lowest common denominator. I'm going to list the multiples of both of these, the 2 and the 7. So the multiples of 2, I'll just take the first few of them, 2, 4, 6, 8, 10, 12, 14 and 16. And for the multiples of 7, I'll take a few of those. I'll go 17, 14, 21, 28. You see I'm just going up by 7 each time, listing the multiples. Now I'm looking for the biggest number that is common to both. Sorry, the smallest, the lowest common denominator. So the lowest common multiple I can see on both those lists is 14. It's the smallest number that appears in both lists. So my new denominator is going to be 14. So I'm going to rewrite those fractions as something over 14 plus something over 14 will give me an answer of something over 14, because you see now that the denominators are the same, I can add those fractions together. But what goes in here? What did I do to the 2 to make it a 14? I multiplied it by 7. Means I've got to do the same with the top. So x times 7 is 7x. So this top now becomes 7x. These two things, x over 2 and 7x over 14, are what we call equivalent fractions. Let's follow the same process now. What do I got to do with the 7 to make it a 14? Well, I had to multiply it by 2. So I do the same to the top, which gives me 2x on top. Now that I've got equivalent fractions, I've got fractions with the same denominator, I can simply add them together. So I've got 7x plus 2x gives me 9x. Okay, so I've added those two fractions now to get an answer of 9x over 14. Let's have a look at another example. It's a little more complicated, but the same ideas apply. This time I've got two algebraic fractions, although in this case, instead of just one term on the top, there are two terms on the top of each. But the rules still apply. So I'm looking for the lowest common denominator of 2 and 5. I've listed both sets of multiples, and I can see the smallest number that appears on both lists is 10. So my new denominator is going to be 10. What did I do the 2 for it to become a 10? Well, I multiplied it by 5. So I have to do the same with the bit on the top. Now, if I take 5 and I multiply it by x plus 1, I can write it like this: 5 outside of the brackets, x plus 1. So I'm multiplying 5 by the brackets. Over here, for my 5 to become a 10, I multiplied it by 2. So I'm going to multiply the top of that fraction also by 2. Once again, writing it in form of 2 outside of the brackets. Now I can see this is something I can expand using my distributive law. So I can rewrite those fractions as, when I expand this, 5 times x gives me 5x, 5 times 1 gives me 5, and the other one, I can expand 2 times x gives me 2x, 2 times 3 gives me 6. So having expanded the brackets, my fractions now become this. I've got common denominators, so I can just add those two things together. So I'm going to take this and I'm going to add it to this. Lastly, I'm looking for any like terms that I can simplify. And I can see I've got x's and x's. I've got numbers or constants here that I can simplify. So 5x plus 2x gives me 7x. A 5 plus 6 gives me 11. All over my denominator, which hasn't changed. It's still 10. So I've taken that and I've simplified it down to 7x plus 11 over 10. Good job.